Somebody just flashed lobster claw. Good work, dude! That thing's hard. All right, so we need to talk about coordinate systems.
Going after him.
4.
Cool? So, you guys know this one? Talk to? I hope so. Or from Algebra 1 or wherever we start this jazz. Okay, so this is what, standard 2D coordinate system? Give me a little blurb on how that works.
This many over, that many up.
Yeah.
Okay. Like a point here means over and ups. Right?
Yeah. Pretty simple.
Okay. So go over a bit, up a bit. Okay, cool. So this would be your point x, y, right?
Yep.
Anybody had enough physics to know how vectors work? Okay, skip it. We'll talk about it tomorrow. All right, so this is your standard 2D, right? Do you guys know another 2D coordinate system?
IJ.
Yeah.
Polar one? How does that one work? So it's still two things, right?
Radius and an angle.
Radius and radius.
There are a radius and an angle, right? And so that's still got this x-y axis, right?
Yeah.
But now a point, right, a pair, doesn't mean over and up. What does it mean?
Out and around.
Yeah, exactly. So you go out a radius r, right? And then you rotate it up by an angle theta. So this would be your point r theta. And how do you tell the difference? Yeah, kind of. But like, how do you tell? 1, 2. Is that a over and an up or a out and an around?
1.
Good. It's good that you don't know. There isn't usually a good way. Usually it's context.
It's like, don't they tell you?
Yeah, usually they have to tell you. So these are the standard 2D coordinate systems. There are a couple of standard 3D coordinate systems. And I'll give you guys the option. Do you want to learn about them first, or do you want to go play with them? Boring. All right, so here's our new standard place that we're going to live in. Calc3 is really going to be in 3 dimensions. We might occasionally play with higher dimensions. But first we're going to start with an x. What else?
Y and
Y and a z. And I'm going to put them together this way. Any of the physics people want to tell me why I picked that way in particular?
That's all I can think of is that.
Yeah, I can understand this.
Yeah, it's this thing.
Yeah.
The RTZ.
Yeah, you really want that
Quote
right-hand
Isaiah
rule to
from now
work.
on.
There's a good reason for that, but it's lazy. So for right now, just trust me, you want to arrange them this way. So x is overs, what would you call y's?
In.
Yeah, like in and out, front and back.
Yeah.
So usually I'll call this over x, back y, and up z. Okay, so that's the standard Cartesian one. And that comes in x, y, z triples, right? And this means the exact same thing from 2 dimensions, right?
Yeah.
See that? So if I wanted to plot a point, I'd go over whatever x was, and then back whatever y was. And then I have this difficult task on the board, right? Of going up. Just kind of with it? Okay, so that'd be one of my points, x, y, z. Alright. Let's see, how else could I do that? What's the kind of natural thing that you could think of doing? There's another coordinate system that's pretty natural. If you guys would come up with it on your own in a second. That's a good one. Let's skip that for now. That's going to be the third one. So this is the Cartesian one. And that was our first one in. So that was our first one in 2D too, right? You guys are really psyched. Gonna be another polar? Yeah, there's polar too, right? Alright, how would I do a polar point? Well,
Radius, angle, angle. Or something.
that's gonna be the sphere one. Or theta, that'll get me a point in the XY plane, right? And Z gives me the up.
Oh.
You guys see that? It's just like take the other coordinate system you had for 2D, right? And then add an up to it. You guys see how that's kind of natural? All right, so on those I'm thinking out. Ooh, where do I measure theta from? So maybe here's my radius, right? I go out a bit.
You go towards the Y, so that's
Oh yeah, it's got to be in that plane, right? So I'm going to go this way with my theta.
and then pull it up.
Yeah, so that'll get me to something like this, right? And then I want to pull it up.
Mm-hmm.
You guys see that? So, what would you call this one? It's not really polar anymore.
And then tangent pull.
Augmented polar.
Yeah, augmented polar is actually really
Even
good.
that's
Usually we call that cylindrical.
Oh.
Because that kind of polar, right, is sort of making a circle, right?
yeah.
If I thought about a radius and then I gave it all the angles, that'd make a circle. If I gave it all the heights, that'd make a cylinder. Okay, see that? Alright, so how about this other one? This is the one that gets trippy. You want to use a sphere somehow.
So you need arc length, wouldn't you?
Kinda, yeah. You want some kind of funny radius, right? Okay, so this is again in 3 dimensions, right? So I've got an X, a Y, and a Z. And now I'm going to do a, I want to give it a distance, right? But I want to be a little careful because I don't want the distance to mean the same thing as this distance. You guys see how that's not quite right?
Mm-hmm.
The distance that I should be talking about on this one is, well, it's like this distance, right? The distance from 0 to that point. Yeah, it's a little bit like the hypotenuse of that triangle, right? You guys see that? So we're going to give that a letter that reminds us of R but isn't R. What would that be?
Rho.
It's kind of harsh.
Right, a Greek R. Mathematicians are not very creative, right? Okay, so we're going to give it a rho. So that's going to give me a distance, right? That's going to fix a sphere. And then I got to find this point on that sphere. So I need 2 angles, right? What's the one angle that comes to mind? Theta, right? Okay, so I'm going to go, all right, here's my out. And then I'm going to go around a bit. There's my theta, right? And then I need another,
5.
another angle, right? And what's that angle going to measure?
You would measure
Between
up.
Yeah, you'd really love it to measure the angle up. And you know, just because we had to screw with you on one of these, we're going to measure the angle down off the z-axis. So we're going to call that phi. And so that's going to give me a angle down.
not up from the XY, but down from
not
the
up
Z.
from the xy. Okay, so I went out, over, and then off the Z a little bit, so I get a point over here, right? You guys see that? And that's above a point that's on this line, right? But it's not above where the end would swing to. You guys see that?
Yeah.
This is going to be a lot better when we play with it on the coordinate axes that I made. So are you guys cool with these for now? Got the idea?
Yeah.
So the important thing to remember is that this B here is down off the Z-axis because there's no frickin' justice.
Okay.
It, this guy?
Put some
Oh, this thing. Good. Well, you came up with the name already. Yeah. Probably spelled differently than that, but cool. Good. All right. Somebody punch the button there, and we'll play a